So we got about 40 minutes left, so we're going to create some basic shapes in Fusion 360. Is everybody who wants to open Fusion 360 able to? You have to download from the student site like you do in others and then log in. It's a cloud-based product, and it's really new from Autodesk. So it's cloud-based, which is a little bit different. You can work in offline mode, but if you work in online mode, all of your files, you don't keep them on your local computer. They're on the cloud, which is weird. It's different at first. But I find it really nice. I can go to any computer anywhere I want to, and my files are here. You can also invite friends to work on a file with you, which you can't do normally. So it uses the cloud. You can share files, keep all your files in the cloud. You could lose your entire laptop. Your files in Fusion are still there. They're on the cloud. All right. And it works natively on the Mac or PC, which is different as well. So you don't have to boot camp or anything like that. It's just going to work on either. It's traditionally kind of engineering, industrial design tool. But I found in my own career, I've been with Autodesk just 6 months now. So I practiced architecture for the previous 12 years before that. In my own career, a lot of what I ended up doing the last 6 years was digital fabrication. I would design something, I would model something, send it right to the fabricator, and that would become a building element. So I did a lot of this with concrete panels. I would take and I would model the concrete panels, the facade of my building, and I would send that off to a mold maker who would use a CNC router to carve that pattern out, and then the precaster would pour the concrete in, and then that would make the building. That's not a normal process. You know, before now, it's been architect does drawings, contractor interprets those drawings, you get shop drawings back, and you fight for a while, and then you kind of get what you wanted, more or less. That's traditional process. So this is a new process, and we're really going through an industrial revolution in our country right now because of these digital tools. And when I studied architecture, it was all about modernism. So you have plywood, is a 4-foot by 8-foot sheet. Bricks are 8 by 8 by 16. They're cinder blocks. You got bricks are 4 by 8 by 4. Those sorts of modules. And you study Mies van der Rohe, and you guys make a module. You guys on a project where you do everything on the module? That's modernism. And there's a reason for it. It doesn't just hatch out of nowhere. That's industry. So then the earlier industrial revolution, when you think back, turn of the century, factories started producing things on modules. So the factory is spitting out bricks, plywood, steel members, all the same size. Architects take those and put those together. That's the heart of modernism. It's all about assembly. You think of Mies van der Rohe, the devil's in the details. It's how that comes together. And so your assembly of parts. But now we're going through another industrial revolution in our country and then globally, where we've got digital fabrication. You've got additive manufacturing. And I've even seen, now they're layering up concrete. They've attached MIG welders to 3D printers, and they're 3D printing metal and other building materials. So now you can take your design and fabricate. It's called additive manufacturing or subtractive manufacturing. You start with material, a big block of something, and carve it away with a mill, and you're left with your part. So Revit is not a tool for that. Revit's a documentation tool. It makes building information models, and it makes drawings, which is great. Great tool. And it's a huge leap over CAD. But if you want to start to get into direct digital fabrication, you might use a tool like Fusion 360. This is the first program I know you can go File, 3D Print. That's brand new. This is a reality that you guys will face when you graduate, digital fabrication. It's changing architecture, and it's changing the way we work. And so it's going to be a reality as you guys graduate. So brand new stuff. You can also go in here and generate tool paths to carve something out using subtractive manufacturing CAM. So that's why. And I've used this process, not this tool because it's new. You guys are lucky. I had to use things like AutoCAD and stuff like that that's not meant for it and pound my way through it back in the day. But I've done light fixtures, I've done door handles, I've done whole building facades using this process. I don't send the contractor a drawing. I model it. It gets fabricated. The trick there, things like light fixtures, I have to use a UL engineer to design the guts inside. Because I'm the designer, I make it the form and the materials I want. A lot of us, we use architects, form, material, assembly. I design that, and a UL engineer does the lighting. I do the door handle. Schleg did the actual locking mechanism, the bolts and things. I designed the escutcheon plate, the actual door handle. Because if you look around at door handles, they're all really ugly. In my opinion, mostly, or you can get really expensive like Hefele handles, or you can design your own. And you can do that now, design your own, and then that process can work. And that's going to be more, where it's Industrial Revolution, where it's going to be less and less about catalog, and more about customization, which for designers is pretty darn exciting. If you design it what you want it to be. All right, so this is Fusion 360. If you guys will just watch for a second, then we'll actually do. So first I'll show you some of the Create tools. On the left, you've got Basic Create, the blue box. And I call it the SketchUp box because you guys all use SketchUp. A lot of architecture students do. There is a SketchUp that's by Autodesk called Format. You guys played with that before? Right now it's a beta version, but in just like 2 or 3 weeks, it'll be a real version. And that works on Mac or PC because it's cloud-based, so it works on your computer. And the one benefit it has is it brings in an aerial photograph that's scaled to start your work, which is really nice. Otherwise, you're like, how big is the project? And it also goes into Revit, so you can model in Format and then bring it into Revit. It's called Format. Might help you guys. And it won't be a beta really soon. Just go to Autodesk Format in Google, you'll find it. All right, but it's a Format or SketchUp tool because you can model a box, any standard shape, and it works just like SketchUp or Format. We can model a box. You can then sketch lines on top of it. You can click the faces. I wish Revit did this. There's reasons why it doesn't. It's all about those work planes, which are important for parameters, but just making shapes. You can click on that face. Now I can draw on that face. And then like SketchUp, I have a push and pull tool that I can then add to it, or I can carve out and put a bite in this thing. Say OK here. So there it is. A lot like SketchUp. That's the tools on the left. There's Create, and then here is the Line tool. Let's go ahead and do that. We'll do it a little bit differently. If you guys start with the Line tool, you can sketch out. Just click on Sketch. You'll see under all of these, it's deceivingly simple, the toolbar. But if you pull these down, there's actually lots of options for each of these. We'll just do a basic line. It always asks you which plane to draw on. So when you start, I recommend clicking on the ground plane, and then you can click and draw away. When you get back to the start, it'll give you a little blue box to let you know that you've closed the loop. It turns yellow to let you know it's closed. And under Modify, you have the Press Pull tool. You can click and drag that up. Say OK. You can add a second sketch here. So sketch again. Now you can click on any of the vertical planes, ground plane, or now that you've got something, you can pick a face of that object, draw a second sketch, and use your push and pull tool to then modify that. Say OK. So that's the basic modeling. Not much different than SketchUp. The only benefit here is you can go right to 3D printing, file 3D prints, or you can go and route this out. You can also render it, which is really nice.
Can you take these and render that as mapping?
You can. It's not a typical workflow, and I don't recommend it, but I do it sometimes. So, and I'll show you at the end kind of what I've done with this, but yes, you can. The idea here, Revit, different softwares for different scales. Revit is designed to do building scale. If you tried to model something in Revit that's like 1/32 of an inch, what does it do? It doesn't handle that action, right? Because Revit is made for building scale, and all the algorithms are set up building scale. This guy, you can think airplane size and down to little tiny things. So if you need to model furniture, light fixture, that sort of thing, I might model it here. The only trick is you have to get pretty good at modeling here. It has to be perfectly modeled, all closed up. Otherwise, when you export to Revit, the whole thing will kind of explode on you and frustrate you. It's not a normal workflow, but I do it all the time because I want to put in my furniture, I want to put in light fixtures, and if I do it in Revit, Revit's limited. It doesn't do little tiny details. It's not meant for little tiny.
Does a light fixture or not?
What's that?
Like you said, you put in your light fixtures into Revit will act like a light fixture. Like will Revit read it as a light fixture?
If you make it a light fixture family, yes. And I'll show you an example towards the end of how I do that.
Can you import any geometry into Fusion or not?
Yes, you can import all kinds of stuff.
Okay.
So you guys can use, does anybody use like 1, 2, 3D Catch? You use a phone camera or a regular camera, take pictures of an object. You can bring that in, so scans, reality capture, or you can save your model as DXF or FBX out of Revit and bring it in. So you can go back and forth.
Is
Yes.
it pretty clean, like from Revit into this?
Totally depends on your export type.
Okay.
So it's worth experimenting.
Yeah.
And again, those aren't like regular workflows, but you can do them.
What about Rhino? How does it compare to
Rhino is more about form making. This is for manufacturing. So what I'm modeling here, I can 3D print, I can go and use a mill and carve it out. So this is for, Rhino is more about form making. This is about actually fabricating. I can also render in here. I can also go to Revit. So it's got a few more options. But I would not model a whole building here. That's for Revit. That's what Revit does. Students have tried it. I know there's a studio at Yale tried to do it because it got some cool tools in here, but it didn't work out so well. And I've seen people on the Fusion community that try to do it. They can do it like a whole building. I wouldn't do it. I would use a building tool like Revit to do that. You could try. If you do, let me know. Send me an email. I'd love to see your model. All right, so let's delete this. You can do a big window around it like you do in Revit or something else. A big crossing window. And you can hit delete. If you'll take a notice at the very bottom of your screen on the left, there's something called a timeline. And it's recording everything you do. And it's parametric. So you can go back in time and make changes, and the changes will reflect down the chain, which is pretty cool. Or if you just need to go back and change something, you can right-click and edit something at any time. You can also play the timeline, and it's going to show you all the actions I've done. So just know that's down there. That can help you go back in time. That's another cool little feature too. We can go back for iterative design. So let's go back on the right. Here's another cool thing. It's called Create Form. And this uses T-spline technology, which was developed out of a mathematician from BYU. So a professor there figured out how to, you guys have made splines before, like a spline in AutoCAD or Revit. You define points and a squiggly line kind of goes through it. But you never grab the actual line, right? Which is annoying. So you're like, oh, these are cool splines. I can make whatever shape I want to. Then you can't trim those. You can't touch those. That mathematician figured out how to touch a spline mathematically. And so it creates a T shape because you can go out and grab. That's why it's called T-splines. So that's the technology that it's doing. And it's like modeling with clay. So you guys can watch me do it for a second and then you guys can play with it. So I click on this purple sphere. So I'll say OK. And I can create a box. Real simple. I'll do it on the ground plane here. So here's the box. And I can push and pull on this thing. I can give it a height. I can also drag these little double arrows. And I can increase or decrease the resolution. A little hint is you don't want to do this. Because at some point your computer will crash, and it's really difficult to model that way. You can actually see there's a lot of detail here, because there's a ton of curvature information here, even without really high resolution. So it's unnecessary. So don't get too crazy. Once you're happy with the number of faces and the height and width, you can say OK. And now I can edit this thing. You can see I'm in edit mode. And when I'm done, I can click Finish Form. So what it's got that's unique to any other CAD program I've seen is a do everything tool, which I find really nice. Other CAD programs, if you need to move something or rotate something, you've got a bunch of buttons. And so this makes it a little bit easier. I can click on faces, I can click on lines, I can click on points, and I can edit any one of those. So I'm going to click on the faces to show you. If I right click, I can say edit form, and I can rotate, I can move either direction, or I click on these blocks, I can constrain it to one surface, or I can scale in any direction, shrink and pinch. If I hold Alt on my keyboard and move, I can then add material as well. All right, so that's the sculpt environment. So let's go try it out. I'm going to say, I'm going to undo. We'll go back to the same place. So you go undo one further. You click on the purple sphere. Say OK. Then you click on the Create tool, this box. Click on the ground plane. You just sketch out a box. It's essentially the base of this. You can drag the height. You can adjust the resolution, but don't get too crazy. Little arrows. And say OK. Then you can click on any of the faces and right-click, and you have the Do Everything tool called Edit Form. You can move and change. There is one big no-no here. This is a product meant for fabrication. So if I take and drag this all the way through, like that's sweet. That's exactly what I wanted to model. It's perfect. But you can see the problem. I've dragged it through itself across the lines. It's no longer manufacturable. So to manufacture something, I need it's watertight. It's called watertight model. It's got to be one solid exterior skin. So I wanted this shape. I'd have to model maybe two separate pieces and stick them together, or add some material to the bottom. But I don't want to drag it through itself. And if I did drag it through itself, you can see it doesn't crash or anything, but it won't let me finish the form until I undo that. So every beginner, including me, that's a common pitfall. You try to drag this thing through itself. So you guys can play around with that for a second, and we'll look at something else. We'll do just two more functions, and you guys can play with rendering in the software, which is kind of cool also. Okay, you guys ready to try a little something different? Okay. So go ahead and do Control-Z on your keyboard, undo until you have just the basic box shape again. If you undo too far like I just did, there's a replay, a redo box. Get to this point. You can watch me do it first, and then you guys can do it. This is a parametric program, so you can add parameters to this. So I come to the top, and I can click on Symmetry, and I can do some mirroring. If I want to mirror down the center of this, I can say this left side is the same as this right side. And you can see it puts a green loop all the way around. And I'll say OK. I can put symmetry the other direction as well. I can say the top is the same as the bottom. Now it's got a green symmetry line the other way. Now if I click on this corner face, you can see it highlights all the corner faces. On symmetrical sides, I can right click, and I can say Edit Form. And now it's going to adjust those all equally. Or if I pick on one of these points, I can then adjust that point up and down and start to create that form. With symmetry, know that it's easier to cross your lines. So this is where you'll get hung. You guys usually won't drag something all the way through the whole model. But with symmetry turned on, you might be affecting a point over here, not realizing you're dragging the lines across themselves. So play with that for a second, and then we'll show you just a couple other features you can do for modeling. You can really quickly start to see that whatever you can imagine, you can create. And so we're starting to see designers and manufacturers all of a sudden make forms that you couldn't do just a few years ago. Stuff that was impossible to make. Now we can make it. All right. Let's go ahead and undo again to get back to the box. Just hit Control Z a couple times. Back to the regular old box. Now one other thing you can do here is this is all very curvaceous. Curvaceous can be very nice, but maybe you don't want it to be curvaceous. You want something sharp, sharp angles. You can do that. So if you click on one of your edges, or if you hold, I think, Shift and click some more edges, you can grab some of these edges, and under Modify, one of the options is called Crease. If I say Crease and say OK, it's going to crease whichever edges I have selected and none of the others. So you can start to make these sharp points wherever you'd like them. So crease and uncrease, that's pretty helpful. You can start to create those sharp forms. So play around with that for a second, and then we'll go ahead and say, up on the top right, say Finish Form. We're not going to undo it this time. You can leave it what it is. So maybe put a little bit of attention to this guy. And then say Finish Form. We'll show you one other thing. When you finish the form, it takes it to what's called a solid body. You can no longer edit this thing. It is what it is. If you want to edit it, you have to go back to Edit Form again. So you find on the timeline your little purple sphere. You can right-click, and you can say Edit. Now I can go back and edit that again. So that timeline comes in really handy. Finish Form. A couple other things about the user interface. If you look up at the top left, you've got your units. This is where you can change it. The default's millimeters. You guys are all working in millimeters right now. I know that's the default. You can click on that, and you can change that to any standard SI or imperial unit there. You've got your sketches and bodies. So your bodies are your 3D objects. Your sketches are the lines you've drawn. I should go back in time and see the sketches I drew to make those previous shapes. So that's your little browser. It's like layer control, essentially. And this thing will grow the more things you make. You can make bodies, components. If you get really sophisticated, you can start to make assemblies. So you pull these together. I'm actually going to be at Cal Poly next week, and they're doing a digital fabrication architecture course. They're using Fusion 360 to make curtain panel components. So you know right now if you do a curtain panel as an architect, you pick certain profiles, certain glass shapes, and it is what it is. They're actually going to start to design their own spider glass connections, their own profiles. And so you can use this tool to do that. You can actually start to assemble different parts to make up an assembly, what's called an assembly. So there's assembly buttons up there. You can do rigid connections, you can do hinged connections, and start to actually make something that actually has hinges and connections, like a real part. All right, let's look at another one of these shapes. So over here, if you just move over to the right of what you've done, you've already hit Finish Form. You have these sketch tools. So if you pull this down, you can see there's a bunch of options. So the first one is a line. We'll go ahead and do a line. Make sure you draw on the ground plane. And then draw a simple line coming out here. You can hit, I think, Escape when you're done. And if you come over to Sketch Line, the next one down, or a couple down, is called Spline. You can do splines in here. So I'll do a spline. And hover over that line you just drew. You can get a snap to the start point of that line. So I click once. I can click again, maybe do 3 points, and then back to where that line started. Okay. And hit Enter to finish that up, or Escape. Actually, probably would have been better. I'll try that again. I can do splines. 1, 2, 3. Click to wrap it up and hit Escape to be done. I guess Enter. My bad. We'll switch back and forth between the programs and I forget which does which. It's always different. So 3 points. Stay on the endpoint and hit enter. You know you're good if it turns yellow. You made a closed shape. That's the trick at the end of the day. So you got a closed shape is what you want. Now if you go back to your create form button, we'll say OK. If you pull down the create, you've got different options. One of these is extrude. So if I click on extrude, I click on that. It's going to ask me, what's your profile? So I select my profile. Here's the profile. And I can click this white arrow and drag it up. And you can see it's not following the spline perfectly. That's because the default faces are 8. If I hit the up arrow, I can increase that to 9. On mine now, it's working pretty well. As I increase the number of faces, I'll find kind of an optimal, where I don't have too many faces, but enough to get the curve to come out precisely. And then from here, I can go ahead and say, OK. Drag it up a little bit more. And there it is. Now I've got one of these sculpt bodies extruded from a sketch. So you can be more accurate. I start from a sketch, extrude that up. You can see it's not watertight though, it's got open ends. So to finish this up, if I go to modify, I can do what's called fill hole. And if I click on the very top of this thing, just once, it's going to fill that hole and make it a solid body for me. And I can say OK and repeat that on the bottom as well. So modify, fill hole, click on the bottom, and that's going to tuck it up into a shape. So just another way to make a shape. And I might want more faces and things, get them more what I want it to be. But that's another shape making method. And you guys can just watch up here for a second. There's several others. I can make faces. So let me finish this form. I can come back and I can do create. I can do faces and just straight up start drawing faces. They each have 4 sides. I can say OK. So I can just start making faces. There's another way to start. Or I can come back, create form. You can do surfaces, which are pretty helpful as well. So planes. And these have some of these same tools. I can come add some resolution. And I can modify those if I want to pick up like this corner. I can pick up the corner here. Again, it has 0 thickness right now. So I want to come back and I can say modify and thicken. Somewhere in here. Thank you. So I can pick my object and I can then thicken this thing and say OK. And now that's a solid body. So you can see there's a bunch of ways to create these forms and a lot of ways to modify them. Bridge, if you put a hole in something, you might be able to bridge the sides back together. You have all sorts of options. So I'll say finish. All right, so now I'll do this next step. You can start to render in Fusion 360. So if you zoom in on that body you created, one of these 2 bodies you've created originally, you can right-click and find the Appearance drop-down. And if you click on these different appearance libraries, you've got metals, you've got other woods. You can come in and you can click these. You can also edit them. They all take their own images, so you can bring in any image file. So if you're doing a couch and you want a certain fabric pattern on that, you can find that fabric pattern, bring it in. Concrete, whatever material it is, you can make your own. But it has a bunch of great materials right off the bat. So let's apply a wood material. You can apply it to an entire object, like I just did. Or you can click on Faces. You can apply a material just to a certain face, a certain side of the object. So you have 2 options for that. Faces or the entire object. So apply some materials. Oops. and say close. So once you've got a couple materials here, you can come over here to the render environment. So in the upper top left, you've got model, and then you scroll down to the bottom, you've got something called render. So come here to the render environment. So now I'm in render mode. You can see it turns off those extra lines for me. And the one thing that we'll adjust here is called environment. It looks like a little lamp. And we'll pick the one called plaza. So again, little lamp, it's called environment. Then pick plaza. The background color is going to go to blue. We can click custom color if you want to and change it to any color you want to. And you can see there's a bunch of options here. Plaza is just one of them. That affects how the highlights work. So I'll say close. And the next step is to click this little blue sphere. That's the render button. So click that. It's going to start to render. It's going to start to ray trace. You can see you can watch it count iterations up. And the more the iterations it does, the cleaner and clearer your image is. And once you're happy with that, you can say pause. And you can save that image out to a JPEG. All right, so that's rendering. Kind of fun. And now I'm going to go back just to the model environment. If I wanted to bring this to Revit, I go up to the File, Export, and the one you want is called SAT, because you can bring SAT files into Revit families from there. So we've got just 9 minutes left. I want to just show you some of the possibilities, how I've used it, and give you maybe just some ideas. So just a couple of things. This is me, program manager at Autodesk Student Expert Program. If you guys Google Autodesk Student Expert Program, because you had me come to your school, you guys can get 500 points. Is anybody a Student Expert right now? Not yet? So you can get on there, you can find me, and be my friend. I need more friends. I'm Student Expert. There are job postings there. Employers specifically looking for students who have Autodesk skills. And you can also be my friend. You can get 500 points because you had an in-class presentation. Student community, you guys have to go there to get all the software for free as a student. This is Autodesk Pier 9. So this is in San Francisco. If you guys ever make it out to San Francisco, you can try to stop by the Autodesk Gallery. It's free to the public, and there's some really cool things to see there. And right by that is Pier 9. It's a big fabrication studio. And artists and residents come. It's very competitive. We have artists come, and sometimes students and faculty come as well in the summertime, and they will work in this fab lab. So this is Anouk. She's a fashion tech designer. So she's using this process in 3D printing to start to create clothing. This is another student there at the fab lab, and she's looking at some hydrology. So you can see she's using a CNC router to carve these pieces out. This is one of those mills I was talking about, so it's a Haas machine. Those are made in California. Starting with a solid block of aluminum, and then you carve that away to get to your part. This is a 3D printer. So again, in Fusion, you can go File, 3D Print to make your STL file. You can take right to the 3D printer. And this is a water jet. This is where Fusion 360 can come in really handy as a tool to start to create the tool paths, to carve things out, and the 3D printing files. Pixlr Editor, it's a good way to edit your images. These are some of my sketches, so it's got some really cool algorithms for sketching and doing post-production for your renderings. If you guys bring in trees, it works on Mac or PC because it works in the Chrome or Safari. And you guys can use this for free. Pixlr, just Google Autodesk Pixlr, Pixlr. 123D Catch, you guys mentioned you'd use this a little bit before. You take pictures of an object, and you put all those pictures in. Again, it has a web browser version, so you can use it on any computer. Bring your pictures in, makes a 3D model. Autodesk Sketchbook. These are some of my sketches. You guys can use Autodesk Sketchbook Express for free, or you can ask your school for free. You can get network licenses of Sketchbook Pro. You guys can use it in the computer lab. You want to use a little digital pen for this, or on like a tablet or a touch screen you can use a pen on. You can color with Copic markers and not get the marker all over your arms. It's on the computer. So this is an example for Fusion. So you can see I'm designing this facade. And so I start off with sketching. So I could sketch this by hand on trace paper. I'm using Autodesk Sketchbook to sketch this out. So I have these pivot arms, and I want to pivot. You can see the top pivot stays fixed, and this whole thing can pivot upwards to start to create a facade. So here's my facade sketch on the right. You can see they fold like scissors, and they start to reveal the glazing behind. The idea here is the farther it folds up, I'm exposing more glass, but the overhang gets deeper. You can see the diagram on the left. Overhang gets deeper as that folds up. I might use a simple piston to push these things up and down on that architectural facade. So I can model those little pivot arms in Fusion. Fusion has an A360 dashboard. This is the cloud part. So you can see all of your design work in Fusion. You can invite your friends to the project. You can share your projects out publicly. You guys also, as students, can use the A360 for storage. It has 25 gigabytes on there of storage, and you can view your files in it. So it's pretty handy. Use A360, and you guys can use that for free. You can even set up calendars and schedule. If you guys do a group project, you can use this to collaborate. Put your dates in there. You can even do polls. So here's a Fusion design. So I want to model one of these little pivot arms. So I can sketch that out in Fusion, like we just did a second ago. Sketch out the accurate dimensions of that. And I can use the sculpting environment to pull that up off the sketch and then create the shape and form I want this to be. Then I can use, remember that little blue box on the left that had the more rational shapes? I can use the more rational shapes to then carve out the connection pieces on this. So little cylinders and holes. So you can see this has a mouth on the left and an insertion connection on the right. I can start to put these all together. I can render it in Fusion, of course, like we just did. Fusion does cloud renderings, like Revit does, and as students, you guys can use that for free. Cloud renderings. It looks a little bit different, but it does the same thing at the end of the day. I can create drawings of this in Fusion. So if you needed a fabrication drawing, you can do that. I can then cut this out. I can generate tool paths. So I can create tool paths for my design. I can do new setup. I can do facing and slotting. I can do adaptive clearing, start to carve this thing out. This is where this tool, it's not a toy, Fusion 360. It's, you can actually go and manufacture your parts. And I can simulate this and generate the tool paths. So here it is. You can see the yellow part is this stock. So I'm carving this from a certain size block of aluminum. And I want, at the end of the day, that blue part at the end. So you can actually simulate the drill bit, whatever's going to go around and cut that thing out. That's a lollipop head. It's going to carve out those curves. Generate the tool paths. The blue are cutting, yellow's moving. And you can simulate that thing. In Fusion, it'll actually move around slowly. You can watch it carve out. This is a PowerPoint, so I'm skipping from one to the next. This is the first pass. It's a roughing pass. So you can see there's roughed out of aluminum. Then you'd add a smoothing pass to go back like sandpaper and smooth it out. I can also go up here and I can go File, 3D Print, and I can preview the mesh. When you 3D print something, it turns everything into flat faces. The first thing I 3D printed about 6 years ago was a huge concrete panel for a building. And it had this beautiful curve in it. I sent my model to the fabricator. They, as fabricators do, took my model literally. They CNC'd it out, poured the concrete in. Client was there, big unveiling, huge crane, lifted up my concrete panel, unveiled it, and the whole darn thing was faceted. Looked really cool in a really bad way. It was like face, 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 instead of the smooth curve I wanted. That's what that was pre-Fusion 360 days, so I was using some older tools. Looked fine on my screen, a really big scale, didn't look so good. So 3D printing and even milling, it's these flat faces, we can do the STL file format. So I can go back and I can change. I can say low resolution, medium resolution, high resolution. It's kind of like image resolution, but in 3 dimensions. You say, okay, you make your STL file. Or you can send it to Mesh Mixer, which was on that list of downloads. Send it to Mesh Mixer. You can set up your 3D print bed, make sure it's going to fit before you 3D print it. Make sure everything's good. There's a lot you can do in Mesh Mixer to actually edit this thing from here. It's like modeling with clay, and you can actually edit before you print. So here are all the file output types. You can go to a lot of different other programs from Fusion. So your trick from going Fusion to Revit is to use an SAT file. So I've generated this arm, and so I can make a family. I can take a nested family, put 2 together, start to create that arm, add a panel, and then start to control a building facade. You can see on the right there. So here I'm in Fusion. I export an SAT file. I go to make a new generic family like we did today, but I'll import CAD. I'll bring in my SAT file. And I'll set up some reference planes. In Revit, reference planes are really important. When I bring over something from Fusion, it's just a dumb object. I can't make it stretch. I can explode it and add materials, and that's about it. So if I want this to be parametric, I have to add some reference planes that I can then grab onto. We did this today, work plane based, always vertical. I flip the defaults, so this can go onto the facade. Here's where it gets complex. We did some basic parameters today, but I added some geometry, basic math, to figure out, rotation math is challenging, but triangle math I learned in high school. Sine, cosine, to find the legs of the triangle. You hoped you'd never have to think about that again, right? But if you want to do some of this complex family editing, you go back and think about that. When I do that, I can find the triangle, I can find the 2 points. Then I can make this darn thing move. So I can put some sine, cosine, find that, and now I can find the center point of each of those. Now I can nest it into another family, so a family and a family, put 2 together, and now I can animate this thing. Let that thing grow. So now you can see the one pivot on the top needs to stay fixed. The rest of it goes. And I load it into my project. I can use Dynamo, like we did today, to control the facade and control those parameters. And there's my loaded family in here. And then you guys know this part. You can do cloud renderings in Revit.
Can you make like some animation out of that, like moving panel?
Animation.
Yeah.
You'd probably use 3D Studio Max for that. That would be the best tool. That's more complex, but you can do animations. I'm a big 3ds Max user. I use it a lot in my architectural career, but it's another tool to learn. But that's where you can do all the animation in 3D Studio Max. I can do post-production in Pixlr, so I can add cars, trees, people, and run filters on this thing, and then look at that rendering. So there's my building with Fusion 360, Revit, and Dynamo all used together to create that facade. So you can see my little pivot arm. That was the one thing I modeled in Fusion. Everything else is Revit stuff. So it's just that one little detailed element. A real quick trick on rendering, use cutout maps. I would never model that screen. You guys know how to use cutout maps? Those of you nodding your heads, everyone talk to the head nodders. You don't model that sort of detail in Revit. You use a cutout map. Find it in materials, play with it. Black and white images will create holes in your materials without modeling them. So if you're taking notes, cutout map in Revit, figure that out. It's an important one. Cool. So I can set this up. It does more for 3D printing. I can generate scaffolding so it 3D prints properly. I just want to show you guys I'm going to go through laser cutting really quick. In Fusion, you can pull off faces, and you can use those, save those as DXF files to laser cut.
Can you test?
What's that?
Test in comparison
You can nest, yeah, in Fusion and in Revit.
Does it automatically nest it for you?
What's that?
Will it automatically nest it for you? or-
No, you have to do it yourself. So I'm just taking this, it's a car body, and I'm just slicing it in Fusion. So Fusion, we're drawing lines, I'm slicing this. Then I get these sketches all the way through it. So it's a car body, I save those out as DXF files. I can bring them into AutoCAD, Revit, or another program to lay those all out, and then laser cut that. Stick a stick through it, and there it is. My car body, I can put paper mache or fabric over this to then create the thing. If you learn 3D Studio Max, you can also take your Fusion shapes, export a low poly model out. You can reduce polys in 3D Studio Max and unwrap it. That's technology for like unwrapping a face and painting on it, but that's a UVW map like we talked about earlier today. Unwrap it, and you can take that to AutoCAD to laser cut that out. There's some blogs on how to do that, but you can do it. Knowing you can do it, it's another thing you can do. So again, in Fusion, you guys did this today, sculpting. You can make all of these complex shapes really quickly. And here's that lighting example I wanted to show you, and then we're done. So I can sculpt this in Fusion. And perfect transparency, I had to do this twice. My first model wasn't perfect. I brought it into Revit, and the whole thing like unwrapped. So I had to try it a second time. That's the one downside. It's not a regular workflow. Your model in Fusion has to be well done. And some of the little things might explode when they go to Revit. It has to be totally closed, totally good. I can model these little tiny details in Fusion. And of course in Fusion you can render it to kind of play with the materials. They can save it as an SAT file, bring it into Revit. I have to explode it to apply materials again, but now I can bring this as a Revit family. So here it is in Revit. And once it's in Revit, I can make it a light family. So if you play with the Revit lighting families, there's a little light source. Students get hung up on those families. The light source is not a light bulb. It's the resultant light. If you want a light bulb, you need to model the light bulb and then give it a self-illuminating material so it glows. Otherwise, you just see the resulting light. You can bring that into the family. And don't cover the light source with geometry, or your project will be dark.
Could you make that geometry like 90% or 10% opaque?
Not with that light source. The light source in the family needs to be below. Sometimes I'll put it a couple inches below. It's just the result in the room. You don't want that to shine through any materials. The light bulb can. That can be self-illuminating, and that gives you the effect you want of it glowing. But that's tricky. When you do those families, there's two separate things. The light result in the room and the actual little light bulb.
But you could make the casing of it almost somewhat transparent so that your light goes all the way down and then somewhat comes up.
Don't do it. You can make it, just like I've done here. Let me show you the final rendering. I've got the semi-translucent material and the bulb glowing, but my light source is below that. That's when I do my luminance renderings, which you guys can do in Revit. Check an luminance, you can check your light values. You want that to be accurate. It's hard in our brains, or as architects, we think things very literal. But a few of these scientific things, you got to separate it. There's a light result in the room, and that's a lighting map, and then there's the actual, what the fixture does, a little light bulb. So you've got to do both separately. So I can do my luminance map. And so here's a furniture example. I modeled this in Fusion. You can play with the different materials and bring it into Revit if you want to as well. So that's it. Thanks so much for being here. And it was really quick. We looked at Revit, Dynamo, Fusion, all in just a little over 3 hours. So at least it gives you a taste of a few things you can do. So feel free to play with those, learn some of those tools, and step by step. If you guys make something really cool, email me or find me on Autodesk Student Expert. I'd love to see what you guys are doing. Cool. Thanks so much, you guys. And can I take a picture really quick to prove that I didn't just go on vacation? I know we've lost a few people, but you guys have classes. You guys are going to die hard stuck to the end. The smile. Nice. I will not put that on Facebook or anywhere. It's just for my own documentation. All right, thanks so much, you guys.
Yeah.